Hello, customers and partners. Hello at HP Cosmos. My name is Björn Zimmermann. I'm application specialist at HP Cosmos, and I welcome you here today in our webinar with the topic of gate stability training and in particular perturbation training, which is our new tool. I think we're good to go in general. People are still coming in, but yeah, we can simply start. So today's topic, the perturbation, is like as part of a series from another webinar or from previous webinars already. So feel free to go to our YouTube channel or to our website and find the recorded previous webinars. And the webinar today, the perturbation, is the second webinar of that kind. The previous webinar was held 2 weeks ago at HSH Lamprecht, our German customers and our German partners, with the speaker and let's say the lady behind, Sabine Lamprecht, and she was telling about the perturbation. And here in the screen you see this is on our YouTube channel. So within this webinar today, take your cell phone and you will see and you will get some QR codes. And this QR code will guide you to our YouTube channel and will get you the recorded webinar from Sabine Lamprecht in German language. But YouTube has a function to automatically translate, to transcript and to translate into any language. So just follow the steps 1, 2, 3 to get the subtitle and to translate it to your whatever language it is, and learn more about the application behind gate stability training. Today, my focus, because of my background, I'm not from the medical field, I'm more from the sports science field, but working for HP Cosmos and supporting our customers worldwide since more than 10 years. I will tell some, let's say, more technical facts, some handling facts about the perturbation. So, the big topic for today is the fall risk. People are falling. People are stumbling. People are falling down. Millions of people actually fall every year. And each single fall carries a very high risk for some more injuries. So for example, if people are falling, they can have a broken hip, broken arms, shoulder. So that means starting from this initial event, the fall, they will get some further injuries, and what starts is what it is called a vicious cycle. That means people are getting weaker and weaker and the situation is getting more worse. Just by the event of a fall. If they fall, it can happen another severe injury. Which diseases are prone for a higher fall risk? Probably one of the high-ranked diseases is morbus Parkinson disease. And just to give you some numbers, in the years from 1990 to 2015, the amount of people suffering from morbus Parkinson disease has doubled to 6.9 million. That's about the population of New York City. And the forecast is even worse. That means researchers are expecting an amount of people suffering from morbus Parkinson up to the year 2040 to be like 14.2 millions. So that's a lot. Why I'm telling this? Morbus Parkinson is very prone for a fall risk, just as one disease. There are many other diseases as well, like stroke, orthopedic issues, or others as well. More than 50% of the people, they fall multiple times a year. Not just a single time, multiple times a year. And this mainly happens due to slips and trips. I will explain this a little later. And those slips and trips, they happen indoors or outdoors. And a side effect or another problem is the reaction and the dual task ability is also is significantly limited with those peoples. So that means, yeah, the dual task ability, if they walk and if they talk at the same time or take the cell phone, or I don't know what can happen to create a dual task, this is a critical fact, and this will cause more insecureness and instability. So beside Parkinson, also age. The age is a very important factor for a higher fall risk. 50% of the 80-year-old people, 50% of those fall at least once a year. That's a lot, to my understanding. 10% of those people, of those falling each year or once a year, 10% of those, they will have serious consequences resulting from this fall. And as I said, it's not just the fall or the Parkinson or the stroke. This is also creating other problems, like broken arms. So they will stay in bed and they will get weaker, and yeah, the situation is getting worse. Typically the falls happen in walking. They're not happening in standing. They're not happening that much in sitting. They appear while walking. This is important. And this is what we can also use and where we can benefit from a treadmill that is safe and offers such kind of features for rehabilitation. Therefore, the fall prevention training is already included in many international or European or international guidelines. Guidelines for sensomotoric disease, guidelines for stroke, guidelines for orthopedic belongings, and so on. So fall prevention and training is already set in many rehabilitation sessions, and therefore in the guidelines as well. In general, the rehab settings, the approach is a top-down approach. Or in other words, like also the HP Cosmos slogan is, who wants to learn to walk must walk. So this is the target. The people don't want to get better in balance. This is not something that is realistic for them. They want to walk. This is the main target or the goal for them. So, and the benefit of using a treadmill in a rehabilitation setup is, there are different benefits. One of the biggest benefit probably by using a treadmill is you can do, and it provides many, many repetitions. Repetition is the goal to the success here. To overcome the issue, to overcome the disease, and to overcome the gait instability. A treadmill provides many, many repetitions, many hundred repetitions per session. That means many hundred steps. And those are secure with the use of a safety system like our safety arch in combination with a harness. In addition, and if you know our product line, HP Cosmos offers some more features like an unweighting system. So our Airwalk AP. This is a body weight support system that is unloading the body weight, and therefore it's stabilizing, it's verticalizing the people, and it's also very beneficial in rehabilitation setups. Also our RoboWalk expander cable system. Our RoboWalk expander cables, and you will find some more information on the website or in YouTube, for example. Our RoboWalk expander system is also helping the patients and the therapists. And also we do have many handrail types or arm supports, and all those different features can be found in our user application manual for rehabilitation. So here in this QR code you will get a link to our website, and feel free to download it, the application manual, and in that application manual you will see some more explanations of the different features, how they help in a rehab session, how you can use it as a therapist, what are the benefits. And in that application manual you will find some more QR codes, some more links to YouTube videos using that particular feature, what is explained there. Okay, so what is important for gait stability and in a field of that perturbation training? This perturbation training is actually considered or can be explained as a reactive balance or reactive stability training. Reactive means people are walking and they have to react. They have to react on an event, an external event. It's typically not an event that happens from the inside. It's an event that happens from either they are stumbling on cobblestone or on a cable. And such kind as an event, they have to perform a compensation step. That means they're stumbling and then they have to make a step, a protective step to overcome and to stay in a safe position. And this is the problem, because this is not happening and this is not possible for many people because of their general weakness, of any kind of disease, of slower reaction time, of the dual task ability. So there are different reasons why they cannot do such kind of a compensational step or a protectional step. The traditional way to do perturbation training or to do such kind of reactive balance training was a manual assessment, a manual push training or pull training. That means the therapists are standing behind the subject, behind the patients, and they're randomly pushing them, that they have to do this kind of protectional step, or they're pulling them. So this is, let's say, the simple way to do it, and this is a traditional way, the push and pull training, or even the push and pull tests in the assessment. But nowadays, this can be done also on a smarter way, on a more technology-based way, by using a treadmill. So this treadmill here, the model name is an HP Cosmos Quasar treadmill, but the new feature and the main feature here is our MCU6 control panel. And this new control panel is also available for this model and for other models as well, like our smaller treadmills, like the Mercury or the Pluto models as well. So this is the heart. This is the, let's say, brain behind. And this brain allows us now to create disturbances. It can create these perturbation profiles. And what it means is actually the treadmill allows to create very, very short and very, very explosive accelerations. That means it can accelerate from one moment to the other with a blink of an eye. Within a few milliseconds, it can get faster and go back to the normal speed or the previous speed. And this is so fast that let's say we can say it's 20 times faster than a normal acceleration on a treadmill. It's even faster than a sports car can accelerate. So it's very explosive, and I mean, this is it's a symptom of our treadmill and the quality behind. We have a very powerful motor. We have a very direct drive. That means the communication between everything that happens here and there is very short and very, very direct. So, and this allows us this kind of performance to accelerate very, very fast. On the other hand, the treadmill can stop very shortly, very briefly, also within milliseconds. Let's take 200 milliseconds, for example. It's stopping, and this is simulating a trip. And this, is also very, I would call it aggressive. It's a short burst to stop the treadmill, and this is creating the people some kind of insecureness. And this is simulating, as I said, it's a trip. And in real life, a trip would mean, for example, people are getting, or the foot is getting stuck on the ground, for example, on a cable or on cobblestone or on the edge of a carpet. And yeah, like what we see here in this picture, slips and trips, this is what we simulate with the treadmill. Slip would mean, for example, if the overground is getting faster than your body mass, and in real life, for example, it would be a wet tile in a supermarket or in a pool, next to a swimming pool, or on ice. So at touchdown or at heel strike, you will slip away, and this is what we simulate with the treadmill. And this can be defined in the different methodologies or in the different pattern and profiles from this perturbation mode. What is important here, and as I said, most falls happen while walking. That also means those slips and trips, they happen in a sagittal plane. That means in a fore-aft direction. This is the main happening event. They are not happening that much in, let's say, sideways, mediolateral. And this direction, the Z direction as well, not, which is also not realistically that much. Most events happen in the sagittal plane, and this is what we simulate here with the treadmill. Okay, now it's time for a demo, so you will see it. I will tell you in advance with this, let's say, online format here, and the resolution of the video and the sampling rate of the frequency of the pictures. You may not see this ideally, but I hope you will get a better understanding of what we can do, and we will also show you later on some slow-mo videos to explain this. Okay, I'm asking here my dear colleague, Veronika, to be the patient for today. So, thank you, Veronika. One of the most important facts when doing a perturbation training, there are different important facts when doing the perturbation on the treadmill. The most important one is the safety. That means it's mandatory to use a safety system like the safety arch in combination with a harness, or for example our body weight support, our Airwalk AP, which offers also a fall stop in combination with a harness system. So this is mandatory. The treadmill is trying to get you fall. You will stumble on the treadmill, but you will not fall if you use the safety system, if you use a harness. So this is very important. Another very important fact is this training mode is not intended to be used by the patients themselves. It's intended to be used in combination with an operator next to the treadmill, with a doctor who can observe, who can supervise the patient and can react, press the stop button if needed. So this is also very important. Okay, then for the demo or for the explanation to perform the perturbation training, we have actually two ways to perform it. One way is that we can use fixed profiles. Fixed profiles I will show here on the screen. Fixed profiles, go here on profiles, perturbation mode, activate the perturbation mode. There's an additional warning, as I said before, it's mandatory to use the safety system and to be always next to the subject, to the patient, and to react if needed. In addition, there is also a PIN code request. Okay, and now we are in the perturbation screen. I will show you here on the right hand side. You will see, make it a bit larger here. On the right hand side you will see predefined perturbation profiles. We have slips, we have trips, but we have also customized long lasting training sessions. Those are predefined. That means they are fixed. In this case, they are fixed for the time, yeah, the whole profile is defined by time, speed, acceleration, duration. So different parameters are relevant for perturbation itself. So this is the predefined way, and here in this case I will give a starting speed to Veronica of 2.5 kilometers per hour. This will be the baseline speed. And then I can just activate my predefined events with a click, either simulating a slip or a trip. Here we do a trip. Oh, voila. Okay. Can you do this screen a bit bigger? Yeah, thank you. So one more time, a trip. Okay. So Veronica right now, she's holding the handrail because she's not used to this setup. What is also important to mention here is whatever I show to you today is for demonstration purposes. Veronica is young, she is healthy, but if you have patients with the age of 90 or any kind of disease, Parkinson's, stroke, you have to find a certain level, their level, to perform it. But what I want to show here is for demonstration purposes. So, and the other one is, just as an example, a slip. Okay? This is very fast and a very short moment. In this case, it's 300 milliseconds acceleration and then going back to the previous speed. This is a predefined profile. Right now, I will stop the treadmill. I will go to 0, to the speed of 0. So this was while walking. In advance, I told you earlier, most events happen while walking. They are not happen that much in sitting or in standing. But even though we can also simulate this kind of standing perturbation. Typically, or just imagine, a standing perturbation happens while standing in a bus. You're standing in a bus, want to go to your work, you're standing and holding maybe any handrail, and then the bus suddenly accelerates, whoop, or stops, or like in the metro station, or in the metro itself, so, or in a train. So this is what we call standing perturbation, and this is what we also created here. Where is it? Standing perturbation. Okay. I will ask Veronica just to stand still. Don't hold the handrails. And wait for something. Okay? This is a series. This was the first event. Two more are following. Okay? What we see already is she's doing a compensation step. She has to do it. One more time. Okay, thank you. That's it. So this was the compensational, the protective step from a standing position. This can be done also now sideways or reverse standing. So different directions are possible, and this can be programmed and predefined from the settings. I will show you how to define, how to program such an perturbation profile. It's pretty simple. Go to Profile, Create Profile. This is the profile creator where you can program any kind of profile for your treadmill belongings, not just perturbation. But here is a button, Change to Perturbation. And then we can create our perturbation profiles very simply by adding steps or removing steps and define all those steps. But we do it a little different. We modify an existing profile, and that's why I select a profile and I select the trip. This was the trip profile that we used before, and as you can see here, 300 milliseconds, a speed of 0. This is the simple definition of this single event. If we want to modify it, we can easily do it. Just add another step. And now I will do, for demonstration purposes, I will modify the first step. I will create a random step. For example, like this. I will explain it shortly. Let's take 3 kilometers per hour. So what I did now is I created a random step before, and that random step means before the actual event, before the trip happens, there is another step before which lasts at least 5 seconds. It's hard to see, but at least 5 seconds and at maximum 15 seconds. And at some point in the meantime, it will jump to the next step, and that's the perturbation. So that means Veronica cannot expect or anticipate the event anymore. It will happen at some point. Okay, I will save this profile. I will select a new file name, slow random, and put this on position number 6. Okay, now we go back to the perturbation. I will give her a starting speed. Okay, it's the same event like before, the trip, but now just modified for demonstration. If I activate it, where is it? Random. I activate it, and now at some point, at least 5 seconds and maximum 15 seconds, it will happen automatically. Here we go. Just to mention what we can do as well is, you probably have a keyboard from your computer. Connect this to the USB plug, to the interface. And we can also define for each event that happens, we can define a key, for example, like S for slow, okay, and F for fast. Okay, so this is for you if you want to handle different profiles on a simplified way. You can use a keyboard or any other kind of device with some keys. So this was the way to create, to modify, and to apply predefined perturbation profiles. The second way to do perturbation is even more convenient. It's much quicker, faster for you to set up such a training session. If I go down here, we have the quick generator, the perturbation quick generator, and this simply requires 4 settings. 4 settings. The first one is the total time, the duration of such a training session. Change it here to 20 minutes. We will not do 20, but I will show it. We have the total duration, we have the frequency, how often those events should happen in a minute. 10 times, for example. 10 times equals approximately every 6 seconds there will be such an event. I said approximately because this includes a random factor. It's not, whatever I enter here, it's not fixed. The next one is the increment. That means, according to her baseline speed of 3 kilometers per hour, the treadmill will accelerate or decelerate up to, so plus and minus, up to 4 kilometers per hour. Up to, again, means it's not always 3 plus 4. Sometimes it's just 3 plus 2 kilometers per hour, or 3.5 or minus 2.1 whatsoever. There's a random factor, and whatever I enter here is just indicating the limits. And the last parameter that we need is the intensity. Intensity here is actually defined as the duration of the single events. If that event lasts for 100 milliseconds, so very shortly, or if it will last for 400 milliseconds, 500 milliseconds, so longer. But here we take, let's take 380 milliseconds, and that's it. So, as I said, within a few clicks and within a few seconds, you can easily set up such profile. What we can do now here is we can change the baseline speed. So for example, if Veronika is fine with this speed, we can change it to, let's take 3.5 kilometers per hour. And once we started the profile, and I will do it now, the treadmill will react and will do everything now automatically. If possible, Veronika, try to not hold the handrail. Try to walk freely, yes. It's not easy, definitely. And as I said, the training can be customized, can be created according to everybody's individual level. An older patient, an old lady, aging of 70 years, she will probably have a different baseline speed of 2.5 kilometers per hour and lower parameters also here in the settings. Yes, very good. Okay, so this is the way how to set up a full profile, a training session, in this case of 20 minutes, within a few clicks. And this is very beneficial. And you will see also the patients, their stability will get better. They get used to it. We probably have not reached that status, but we're on the good way. So the people are getting used to it. They are getting better and better. That's the plan. That's the rationale. That's the idea of such a perturbation training. We can also see it here by the heart rate. Heart rate is getting up. And once you notice the people are getting better, for sure you can change the parameters. Is it still okay for you? Yeah. Yep. You can change the parameters, or we can also give another dimension to the training. The next dimension or the next level of this perturbation training will be to include dual tasking exercises, dual tasking drills. How it looks like? Can you do this a little bigger? Thank you. To do this, just go down here on the screen. And what we did is we implemented dual tasking or cognitive tests. This one here is the Stroop test. The Stroop test is well known in cognitive training or cognitive assessments. For example, if I turn it to Veronika right now, she has to name the color of the letters. Not the color of the background, not the word, but the colors of the letter. You can do it. Blue, yeah. Green, very good. So what happens now is we will give an external focus to the subject. The subject, the patient, is not focusing on this perturbation profile anymore. The subject is now focusing on the extra task, the dual task. And as I said before, in real life it would mean people are walking, they're watching on their cell phones, and they're not focusing on walking anymore. This happens in the background. For most people it works quite well, but sometimes you will see people are getting more insecure when they are talking on the phone or texting messages. This is the dual tasking ability. And this is important here because actually what we want to create with the perturbation training is that walking happens unintended. It happens in the background without keeping the focus on walking. Walking should happen automatically, and this is why we can appoint the focus to a different exercise. This is the Stroop test. We also have other tests included, such as the capitals. Guess the capital. What's the capital of Mexico? Mexico City. What's the capital of Switzerland? So this is not to educate people, to make the people smarter. Again, it's just to point the focus on an extra exercise, on a different exercise. Word salad. What's this word about? It's frog. Mathematics. Easy, medium, or even harder. So different exercises just to keep the focus on a different task. Number sequences, or guess the country flag. So what's this flag about? It's the flag of Luxembourg. Many flags, many questions, many mathematics, many dual tasks are incorporated to apply a new level or to apply a new dimension into that gait stability training. Okay, here we see, in total, we see the overall happening over time. We see the heart rate. We see all those single events happening in the meantime. And what we can also do is we can include, let's call it flags, or we can rate, or the subject can rate the perceived exertion. That means we incorporated the BORG scale, modified BORG scale, or the pain scale. Just as an example, if she's indicating her on a scale from 0 to 10, she's feeling like 3, it will be shown here on the graph as well. So this is important after the training. Ask the subjects after the training how they felt, and then that's an important indication for you to create and to modify the next training sessions in the future. Another tool here, it's a full range of tools that you will see today. Another tool here is the metronome. A metronome is giving a rhythm, is giving a beat, is giving a step frequency to the subjects. You can probably not hear it that well. My microphone is filtering the different noises from the background. But this here, you can apply a metronome. We can also show actually her step frequency, her real step frequency now. She has a cadence of 100 steps per minute with a step length of approximately 60 centimeters and a total step count of 1,200 steps already within this time of 12 minutes. So this is important, what I said before. Repetition is the main goal. Repetition is very important for the success in such a rehabilitation session. And repetition means here Veronica already did 1,250 steps. Okay, that's already a lot. Some ideas to give you with the metronome, with the perturbation. And I will stop the perturbation training for Veronica. I will stop the metronome. So now she can walk out. She can get a cool down. I will stop this. Take care. I will stop the treadmill. That was too fast. One more thing I want to show you, I will simulate this. One more thing I want to show you is a summary. After the training, you will get a summary, and the summary shows the average speed, the maximum speed, average elevation, heart rate, the total distance, the total step count, and many different parameters are shown there. And also the step length, the step cadence, the step frequency, many different parameters. But before in the training I was a little too fast, but still this was also saved. Okay, thank you, Veronika. Okay, so just to summarize, the treadmill with the perturbation mode or a treadmill for rehabilitation offers many different benefits. The first one is it is a safe reactive stability training that you can do, and especially in the sagittal plane. Sagittal again means to simulate the slips and the trips. And this is the main event or the main occurrence for when people are falling. And the slips and trips, they can be trained very realistically. You can simulate it very short, very intense. So that means you can create different profiles, you can create different training sessions for young people, but also young and healthy people, but also old people with some different disease. So give it a different baseline speed and to apply the different parameters. You can create and you can simulate training sessions for every different health status and for different levels for the people. And the dual task exercises, the dual tasking in the background, will apply another dimension to that training, to that gait stability training. Because the dual task ability, the reaction ability, is significantly limited for different people. It's not just the age, it's also other diseases like Parkinson's or stroke or whatsoever. So all in all, a treadmill offers many benefits, and especially the new perturbation mode is also very beneficial. The perturbation mode, as I said before, is available for the MCU6 treadmill models. In this case, it's a Quasar, but could be also a Mercury or Pluto treadmill that we will launch, that we will release in the following of this year. Thank you so much. And so far, I'm happy to answer some more questions. If there are some questions already, feel free to type it into the chat box or the Q&A section. One of the questions before was also about or related to the handrails. The handrails are, okay, they will provide security, but this is not a typical situation in real life that you hold something. This might happen in a supermarket when rolling a cart, but this is not realistically. The handrails should be avoided. If the patients are fit, let them walk freely and not holding the handrails. Some patients like Sabine Lamprecht in their clinic, they are using TheraBands, rubber bands, holding them here just to get a better orientation where they are, but they will not hold the people. But it's, let's say, it's a little trick in the background for their orientation on the treadmill. Okay, other questions? How is the gait frequency and the step length measured or estimated? So the step frequency, like I've shown before, the step frequency and the cadence and the step count is measured with an internal sensor, and that sensor provides this information. It's not a load cell like with our treadmills, the Gateway. It's also not pressure distribution. It's a sensor which is connected to the drive belt or to the motor itself, and this allows us to measure step frequency, and the step length will be calculated, and the step count is measured. Other questions? Is there a way to time the perturbation according to phases of the gait cycle. Yes, there is a way, and what you have seen here was kind of randomized. So that means each event happened at a randomized time. That means it can happen, well, let's go here on the treadmill. It can happen at heel strike, it can happen at mid stance, it can happen at the late push-off phase, for example. This is randomized, and this is not according or fixed to a gait cycle. But we can also do it according to a specific gait cycle with the use, or in this case, with the Gateway 3D. Our Gateway 3D is our instrumented treadmill, the treadmill that measures ground reaction forces. And by knowing the ground reaction forces, we know also the gait cycle. And in this case, with the Gateway 3D, we can also combine perturbation and the gateway knowledge, the gateway data, and bring this together. And therefore, we can also indicate, for example, the next perturbation should happen at mid stance, or should happen at heel strike, or with a delay of 200 milliseconds after heel strike. So the answer is yes, with the Gateway 3D, and that means we need to know some more of the gait parameters. What experience has been already gained with the use of perturbation for joint replacement in older people? The other one is a second question, or is it? It's the same. How long post-operative can it be started? What is your recommendation? So my recommendation here is to ask the doctor. This is actually not my background, and this is not the intention of HP Cosmos. We will not indicate, or we will not give recommendations to any therapeutic and to a therapy session, to a plan. So this needs to be discussed in combination with the doctors. If the doctors allow, after a hip replacement, if they allow such kind of training, then that's fine. Simply speaking, hip replacement, not each hip replacement is the same. You can use like a mortar, like a cement, that allows, let's say, right after the surgery, some more intense training, or there are other methodologies to insert a new hip, which do not allow a training right after the surgery. So this is very critical, and therefore it needs to be discussed with the doctors. My experience for that one, to answer that question, is there is no experience from our side or from my side. Okay. The sensor you mentioned, is it only standard with any perturbation with the treadmill, or comes it automatically with the perturbation option? So the sensor is already included in any quasar treadmill or the pulsar treadmill, so the bigger versions. The sensor is already integrated with those models, and in combination with the MCU6, you will get this information already. And on our price list, you will also see the option and the capability for the smaller treadmills, for the Pluto and the Mercury treadmills. So to answer the question, the sensor is not integrated automatically. It's also not integrated automatically as part of the perturbation module. It's a separate feature, I would say. But it's not that costly, but can be integrated into any treadmill. What are the documentation and report functions? Are there screenshots and reports, table or Excel or PDF? Okay, that's a good question, and I will ask my colleagues to highlight the screen again so I can show this. So, report is important for sure, and we have different capabilities. Just to simulate it one more time, I will start a training and I will immediately stop the training as well. As I explained before, we do have here the summary screen. On the summary screen, again, we will see the average, the maximum parameters for the different, or the values for the different parameters. And here we also have the save as PDF or CSV file. So that means we can create, or we can save a PDF file with all the data in the background. All the data does not just mean we see the average numbers and the maximum values of each parameter. What we see is a long list, second by second, or we can apply it every 5 seconds, every 10 seconds. We will see the parameters that are that have been relevant at this time point. That means in total, the PDF or the CSV file can be a very long file with hundreds of numbers, and then this can be processed for researchers in Excel or in any other format, in Python or in MATLAB. So this can be used. This is to create a report as a PDF or a CSV file, and then you just insert a thumb drive, a USB stick here to the backside. To the backside of the treadmill, there's a USB port. Just insert and save it on the USB stick. Or if this profile was very nice, if you like the profile that you have done, you can save the profile and do the same, exactly the same profile the next time again on demand. Okay, can we obtain data for individual step parameters when performing perturbations? The step following perturbation or the one after it. Can we obtain data for individual step parameters when performing perturbations? Can we obtain data for individual? I just need to rephrase it. Just a second. The step parameters like the cadence or the step length and the frequency, this data is, let's say there is a moving average window taken above this data to filter, to smooth this data. So that means not every single step will be measured with the sensor that I told you. Not every single step will be measured, but it will be, let's say, averaged over a sliding window of 3 to 5 consecutive steps. Alrighty. If there are some other questions, no, not now, but feel free to send us an email to get in contact with us. If there are any questions, we are happy to answer it. This video or some more information will be sent to you within the next couple of days. We will send you our new perturbation brochure, our flyer. This will be sent. We will send also some videos and a video recording. So feel free to discuss this topic, to show this information that we sent to you. Feel free to discuss it with your colleagues. If the treadmill with a perturbation mode is relevant for your clinic or for your business, and and then I'm good to go. There's another question. Is perturbation just a software upgrade? So the answer is yes. It's a software upgrade for the MCU6, which is only for the MCU6, so this control panel. That means also, if you decide for an HP Cosmos treadmill right from the beginning, an HP Cosmos treadmill which is state of the art with the MCU6, right from the beginning you can decide, or you can get the perturbation mode with the very aggressive, very powerful drive and the slips and trip simulation can be upgraded at any time, also later on. That means not just from the beginning, it's a software update, or most people and most customers that we already have, they decide right from the beginning to use the perturbation. Again, and just again to summarize, it needs to have a safety arch as well. That means if this is a treadmill without a safety arch, without a safety system, we cannot upgrade it, because this is mandatory. This is for security, this is very important. So it requires a safety arch, but most of our customers in a clinical setup already have a safety system with a safety arch, or the unweighting systemd AirWalk AP. So if this is the situation on site, it's fine, and then we can upgrade it at any time. Okay, thank you so much for listening, for your active support and for your questions. Feel free to reach out to us anytime, and have a nice week, have a nice day. Goodbye.